Our next function topic is going to be composition of functions. So we're going to look again at the input-output model and interpret that as a function performing an action on the inputs to create the outputs. Then we're going to show how we can break down the action of one function, sometimes at least, into smaller actions. And then we're going to use that to define composition of functions. So let me remind you how the input-output model works for functions. So a function is a machine or a process that has inputs and outputs. Each time you put in an appropriate input to the function returns to you an output. And the consistency rule for the input-output model is you cannot put the same input in twice and get different outputs. In other words, if you do put the same input in twice, you will always get the same output. So one way you can think of the machine is as something that performs an action on the inputs in order to create the output. So you start with x, you put it into the function, it does some kind of action to it, and then out comes the output f of x. And sometimes the action of a function itself can be broken down into smaller actions. And let's see how that looks on a particular example. So here's f with domain r and codomain also r. Then f of x equals 2x plus 3 is going to be the formula. So the input is x, the output is for x is 2x plus 3. So the question is, what kind of actions do you have to do to get from input to output? And if you look carefully, there are actually two actions that you do. The first thing you do is you start with your input x and you multiply by 2. So that's the first action. So x becomes 2x. And then you take that 2x and you take that 2x and you add 3 to it to get 2x plus 3. And then each of the smaller actions is itself a function, right? So that multiply by 2 action could be thought of as a multiply by 2 function. Right, so multiply by 2 function takes an input, multiplies it by 2. You end up with a function g from r to r. And then if x is your input, 2x is going to be your output, because if you multiply your x by 2, you get 2x. And if you want to make it look more like an action, you start with x. The arrow does some sort of action to x to double it to make it 2x. So now the add 3 action works very much the same. Your input gets you give it your input and it adds 3 to that input. So if you want to call the function h, and that is also from r to r, then if the input is x, then the output is going to be add 3 to it, so you get x plus 3. And again, if you want to visualize that as an action, you start with x and that gets transformed into x plus 3. So if you want to look at how f works, right? So f, you start with x. The first thing you do is multiply by 2, and then you add 3. And I should note that you don't, and by the way, that 2x is going to be g of x, right? And then the next action you do to that 2x is you're going to add 3 to it. But the thing is, you don't do the add 3 function to x. You do the add 3 function to 2x. So instead of x being the input to your h function, what your input is going to be is 2 of x. So you're going to get 2x plus 3. So your input into h of x is equal to x plus 3. Your input for 2x plus 3 has to be 2x. So if you think about what h of 2x is, you take your 2x and then you add 3 to it to get 2x plus 3. And then remember, 2x is equal to g of x, so that's actually equal to h of g of x. So you can see that we have done in a kind of different way, taken your h and g, combined them to form the function f. So this is exactly how composition of function works in general. So in general, here's what's going to happen. You're going to start with your input x. The first thing you're going to do is to put that x into a function g. Then that g of x will become the input to your next function, h. So you get h of g of x. And that combined function that starts with x and ends with h of g of x is called h circle g. And again, this is created from 2 functions, g and h. So you're going to start with 2 functions, g and h. And right now, g has some domain A and some codomain B. H has some domain C and codomain D. And then we're going to figure out what happens when we try to combine these 2 functions into h circle g. So what is h circle g of x? Well, remember, it's h of g of x. And that means, so if you look at the beginning, x is an input of h circle g. I mean, you can see that because it's h circle g of x, right? But then it's also an input of g, because if you look at the right-hand side of that equation, we put that x into g. So that x has to be at the same time an input of h circle g and an input of g, which means that the domain of h circle g has to be the same as the domain of g. And remember, the domain of g was a, so that means the domain of h circle g has to be a as well. All right. So now g of x is going to be an output of g, because x goes in, g of x comes out. That means g of x has to be in the codomain b. But also, if you look at the right-hand side of the equation again, that g of x is also an input of h, because the second thing you do after you put x into g is to put g of x into h, which means that g of x also has to be in c, because it has to be in the domain of h. And so this doesn't necessarily require b and c to be the same set, but in order to help us not to go too totally nuts, we should have b equals c to make this thing work. So in general, in order to define what the composition of functions is, you have to have g as a function from some set A to some set B. H has to be a function from B, the same set B that was the codomain of g, to another set D. So now h of g of x, that is going to be the output of h, right? G of x goes in, h of g of x comes out, which implies that h circle g has to have the same codomain as h does, right? H of g of x is going to be an output of h. It's also an output of h circle g, which means that the codomain of h circle g has to be d. All right, so let's look now at the formal definition of composition of functions. Let a, b, and c be sets, and suppose we have functions g from a to b, and then h from b to c. Then if we want to define the function h circle g, that's going to start at a, that's the domain of g. It's going to end up at c, which is the codomain of h, because that's the last output that you get. And the definition is going to be h circle g of x equals h of g of x. So let's go ahead and look at an example. So this is some new notation that maybe we haven't used before. So we're going to let r plus be the set of positive real numbers. Without the plus, it's just plain old r, just real numbers. But r plus is going to be considered the set of positive real numbers. And we're going to define g from the real numbers to the positive real numbers by the following formula. It's just going to be g of x equals x squared plus 1. And you can see that the output is going to be a positive number, because x squared is always going to be a non-negative number no matter what x is. And if you add 1, that's going to make it positive. And then we're going to define h from the positive real numbers also to the positive real numbers by h of x equals square root of x. And that makes sense. You can't take the square root of negative numbers, so putting positive numbers in there makes sense. And the square root is always a positive number, so that means the output is going to be positive as well. So let's see if we can figure out what h circle g is going to be, h circle g of x. And remember, the first thing we're going to do is we're going to take that x, we're going to put it into g. Well, right, so we get h of g of x. Our g of x, we have a formula for that. That is x squared plus 1. So we're going to replace that g of x with x squared plus 1. Now the second part's a little bit tricky, because we're doing an output of h, but the input is x squared plus 1 and not x. So before we do that, I want to sort of try to think of h as being an action. So if we look back up at h of x equals square root of x says whatever your input x is, you take the square root of it. So it's a square root action. In comes the input, out comes the square root of that input. In this case, our input is x squared plus 1 for h. And so our output is going to be the square root of that, which is square root of x squared plus 1. All right, so now I think you're ready to work on the first two activities for the PDF file called Composition of Functions. That's one of the ones included with this video. There is a third activity on that particular set of activities. That one's going to be a little bit hard just with what you've seen in this video. So I strongly encourage you, after you've worked on the first two activities, to watch the video called Definition of Functions to help you with the third one. The definition of functions give us a formal definition of what functions are, and that'll help you out with the third activity.